In the first approach, let's try the brute force recursion. Intuitively, we just utilize a nice little property of the Pascal triangle, which is given in the program description. As we know, in the Pascal triangle, each number is the sum of the two numbers directly above it. So let's say we have a function, getNums. It has two variables, row index and call index, which is opposite and ordinate. So these two variables gives us the column index numbers in the row index row. So we could simply build the case row by repeatedly calling the getNums function for the column 0 to column k. So we can formulate our intuition into the recursion. getNums as row index, call index. The value is equal to getNums as row index minus 1 and call index minus 1 plus getNums as row index minus 1 and call index. And the recursion will end in some known base case. So the first row is just a single one, which is getNums as 0, which is 1. And the second case is the first and the last number of each row is 1. For example, the getNums at k and 0, which is the first number, which is 1. And the getNums at k and k, which is the last number, which is 1. Okay, let's try to turn our algorithm in Python. First, we just set a class, solution. Then we define our recursion function, getNum, which have self, and row, and call, which is the opposite and ordinate. So in the first case, if row is 0, means we are in the first row, or call is 0, means we are in the first column, or row is call, means we are in the last number in the rows. Then we just return 1. Then in the rest of the case, we just return our recursion is self.getNum, which is row minus 1, which is in the upper side, and call minus 1, which is in the left side, and plus self.getNum, row minus 1, which is just on the upside, and call. Then we have finished our recursion function. Then let's set our main function, which have defined the getRow, which have self.row index integer. Then we return an integer list. So let's set an empty array ends, which is empty. Then we have to write element inside it, which is for I in range, row index plus 1. Then we just append the element inside it, which is ends.append self.getNum row index, and another variable is I. So we are done. We just return ends, and this time we can just print solution dot get row. Let's say 4. Oh, we forget to we should outside of the loop, which is 1 4 6 4 1. Okay, we are done. Let's analyze the complexity. The time complexity recurrence is straightforward, which is O of 2 to the power of k. So the time is t of k and I, which is the sum of t of k minus 1 and I plus t of k minus 1, I minus 1, and plus O of 1. And we should remember the t of k and k, which is the last number of the row, and the t of k and 0, which is the first number of the row. They are both 1, right? So it costs all of 1 time. Thus, the t of k and m, it will take k choose m units of constant time. So for the kth row, the total time required, which is the sum of all of the operation time, which is t of k and 0 plus t of k and 1 plus blah 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 plus t of k and k minus 1 plus t of k and k, which is the sigma sum of the t of k and m goes from 0 to k, which is approximately equal to the sigma sum of O of k chooses m, and m is go from 0 to k, which is approximately equal to O of sigma sum of k chooses m, and m is from the 0 to k, which is the O of 2 to the power of k. And about the space complexity is O of k plus O of k, which is asymptotically equal to O of k. First, we need O of k space to store the output of kth row. Then, at worst, the recursive call stack has a maximum of k calls in our memory. So each call taking constant space, that is O of k worst case recursive call stack space.